and then some minor ones that we may mention. Okay, first up, if we're taking the log base b of some product, then it just so happens that I can split this up, this product up, as a sum of individual logs. The log base b of m times n equals the log base b of the m plus the log base b of the n. Now this is kind of weird. This takes multiplication of one thing and turns it into addition of other things. Alright? Which can be useful. And those of you who are headed toward calculus, and on the first day, many of you raised your hand. I don't know if you've changed your mind since then, but let's say y'all are still planning on going to calculus. I don't really need to go into this. There's a technique in calculus you learn called logarithmic differentiation, and this is a very useful trick in that case. There, send my piece on that. Okay. Next up, the opposite of multiplying is dividing, right? So we have a similar trick that if I'm taking the log of some quotient, then I can split that quotient up as not the sum of logs, but what's the opposite of adding? Subtracting. So we're going to say the log base b of m minus the log base b of n. And actually, I want to oversimplify this a bit. We're going to practice going back and forth with like some actual numbers and stuff. But one of the things that's going to come out of this is we're going to have probably multiple factors of things up here and multiple factors of things down here. And what I want to stick in your brain is that anything in the numerator in these cases is going to end up being a positive logarithm. But any factor I have in my denominator is going to end up being a negative logarithm. Okay? I'll repeat that later, but I just want to sort of start that now. Okay? So, the third property, to me, is like the crown jewel. It's the one thing that's unique to logarithms that makes them a worthwhile, useful tool. Alright? And that is, if I'm taking the log of something raised to a power, of something with an exponent, I'm allowed to take that exponent and move it out front and treat it like a coefficient. When I was in your case and I was learning about logs, once I was given these three properties, like, I dominated the log problems. Like, I was able to do like everything with just these three properties and turn it into like a simpler problem that I could work, and I thought they were awesome. Now, I get that you may not think they're as awesome as I do, but you're in my class, so they're awesome. Okay? Before we go on to actually do some practical application, not practical application, but plug in some net numbers and whatnot, let's go back to this right here. We said something about this last class that you may not remember. Out of these three numbers, which one is really my exponent from over here? The x is my exponent, right? And something we said that I told you probably wouldn't make much sense is this logarithm is really an exponent, right? That's what this equal sign means. If the logarithm equals this exponent, then the logarithm is an exponent, right? One of the implications of that is there are rules that we talked about for exponents back in Algebra 1 or 03, 05, whenever you learned about exponents, that are analogous to these three properties. Okay? So for example, if I multiply two numbers together that had a common base, does anyone remember what I was allowed to do with their exponents? So what happened there? The multiplying of these turned into the adding of those. Multiplying of these turns into the adding of those. I'm adding my exponents together here, right? Okay? if I did division, what could I do to, with those exponents?
Subtraction.
Subtract them. So just like division there turns into subtraction here, this division turns into that subtraction. And then the last thing is, what if I had an exponent raised to an exponent? What if I had b to the m, but then raised to the n power? That turned into multiplication, right? I can multiply those exponents together. And we have this analogous property here. This thing with an exponent turns into multiplication of exponents. Okay? Truthfully, these guys aren't really going to come into play on the test all that much, but I'm just kind of pointing them out to help you remember these guys here. Okay? I have my own sort of like language that I apply to these guys because I like to keep things nice and succinct. Okay? So I'm going to take these properties, and the ones that are on this side of the equal sign, I'm going to say all these guys are condensed. Okay? What I mean by that is everything that I have is sort of all packed into one single logarithm. Do y'all see that? Over here is just one log, and inside is a bunch of junk. Okay? On the other hand, over here, I would say this side of these properties, these guys are expanded out. Okay, so what I'm going to say on my tests and reviews and stuff is like, condense this or expand this out. And what I mean is take it from looking like this to looking like this, or take it from looking like this and make it look like this. Okay? Your homework won't say it quite like this, your textbook won't say it quite like this, but I don't get it because they're using 25 words to say something that I say in one word. So I don't want to write 25 words on the board. Sorry. So let's do some practice. Which way do we want to go first?